I need to go and get some food in a minute. I'm starving. I'm going to get some food in a minute, but I thought I'd explain something. Oh, saw my hands in the way. Right, so when you've got a drum that's rotating, and you've got your coil opposite the pole, what happens, as we all know, is you have a lensing effect, which basically breaks the drum. So a coil that's opposite, a single coil, is subjective to a number of forces. There's the attraction of the flux, and then there's the departure of the flux, and this is creating a lensing effect, which is breaking the drum when it's under load. So I'm working on this idea of using a laminated style coil, and I'll try to explain it. So we have our magnetic flux. Let's just use south as an explanation. So we have our flux with a south field that's energized to a coil. Now, what I'm looking at is to use a stepped coil. I think that's the way of explaining it. So basically it would consist of 3 coils in series. So we have a coil and another coil and another coil. And the reason for this is we have 3 laminations or ferrites running through, and these coils are wired in series basically. So this coil might be wired to that coil, this coil might be wired to that coil. So as the drum is rotating, what we have is a wave effect. What we get is a wave effect, whereas this coil is fully energized. I'll draw the wave directly above the coils, then you can see what I'm talking about. So we have a wave effect. So if the magnet's in the middle there, we would basically have something like this. So we would have a much stronger field in the middle, and this coil would, all 3 coils would be energized and producing a DC output. Well, not a DC, an AC output, but it will be on one cycle. So as this rotor is moving, to simulate the kind of effect that we would have, if the drum was pointing at this coil here, then that coil would be more energized, so we'd have a greater field there, and we would have a smaller field there, and we'd have an even smaller field on the 3rd coil. So this is the 1st coil, 2nd coil, 3rd coil. Now as the magnet is rotating, continually moving, it would then be on the 2nd coil, in which case we would get this waveform with a stronger field on the middle coil. And as it starts to leave, as the flux is pointing more at this end coil, we would have the reverse effect like this. So it would basically, my hope is to overcome the lensing effect. So, but the coils are in series. So what happens is, when the magnet is at this position where the last coil is mostly energized, we have a certain amount of subtraction on this coil here. We have a subtraction from the overall output. So this 1st coil and the 2nd coil would give a partial subtraction of the power output, which would offset and would cause a ripple effect on the way it's working. That's the theory, that's what I'm going to test, and these are my coils with ferrite in them. I've got to wind them, so I've put they're very small coils, they're very tiny, as you can see. So it's an experiment, it's not the full ad hoc, whatever you want to call it, build yet. This is what I wanted to be able to do with this new build, and it's very well balanced. I have very low vibration on it, it's extremely quiet. I haven't got the motor coupling mounted on the base on here yet. I'm just driving it from the other one, So I've got the motor on the other one to turn this one at the moment. So anyway, what I'm going to be doing is I'm going to wind all three of these coils, and they're all going to be in series, and we're going to see if that effect I'm describing here actually comes into play, or whether or not I'd have to wind coil all the way around all three. Now that's possible as well. I could wind individual coils first. I could wind each coil separately so that each coil's got a winding on it, and then wind another coil all the way around all three. A smaller coil, so I can do some measurements and compare the way it behaves. But it depends if I've got enough room on the bobbins anyway. But it's an experiment. So we would have a rolling effect basically. It would basically roll from the entry point to the first coil, to the middle coil, to the exit coil. So we have this rolling effect where the power output would actually basically be like a seesaw. So it would actually be like this on the input, and as it passes the middle coil it would be like this. This is the kind of output I'm expecting, is this rolling effect. So this pen is basically acting as this waveform here. So we'd have this roll effect as the rotor is moving through the three coils. So anyway, that's the idea. That's what I'm currently working on, and obviously I'm going to be putting my my centrifugal magnet arrays on the back end of here, because if I get a ferrite ring they fit perfectly. So I could use my concentrics on the back end as normal to test that out. So I've been trying to keep everything to scale, to the same scale, so that I can still use existing parts without having to change everything. Obviously it's got to fit in here. The only issue I've got right now is the fact that this hole is a little bit too small for the three bobbins. I've made them smaller, but I don't want to go too small, so I'm just going to file these slots out to accommodate three of the bobbins. So anyway, that's the idea at the moment, is to create this rolling wave. It's a bit like, you know, being at sea and in a boat, and the wave basically comes along and you get tossed around by the wave and you're riding the wave. So this is what I'm trying to do with the effect of this flux, to overcome the drag effect. And the drag would be effectively absorbed by the negative dips, the actual dips in the waveform from the first coil would be absorbed by any negative drag would be absorbed and offset the output on the output coil, if you get the meaning. So anyway, that's all for now. I'm actually uploading a video at the moment which is older than what I'm actually doing right now, because so I'm going to upload that. It's I've forgotten what I did now on it. I did it last week. So anyway, I'm going to be uploading two videos, this one live obviously, and then the other one's going to be on in a little bit. Anyway, thanks for watching. I don't think there's any... Oh, actually I could show this how quiet it is. Let me just hook this up a minute and show you how quiet it is. I'll just connect this to here. And that's at 3,600 RPM at the moment. It's running the LED. I don't want to go too fast until the unit dries out. It's still drying out. So it's just a little test at the moment. Still climbing. Right. So listen to how quiet that is. The drum is inside another drum, so it can't do any harm. The liner drum is there, which is stationary. It protects me from, in the case of if it should shatter, the main rotary drum is inside there, so it gives me a lot of protection, as you can see. Very safe, and it's extremely solid. It's like a brick basically. If I stick the phone directly on the unit, you'll probably hear it. Hang on. Yeah, I stuck the phone directly on the unit there. You can hear how little vibration there is, and we're in daylight right now. So those LEDs are very bright. Yeah. Anyway, that's it for now.